Okay, Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Okay, so today we will continue with MAXCELLENT program day 3. So today we will discuss Muafakat set 8. Okay, so are you ready guys? Okay, so first question. Okay, the diagram below shows the graph of y equals to gt. Evaluate each of the given limit if it exists. If the limit does not exist, give your reason. Okay, so as you can see, you want to find limit gt as t approaching -2. So take a look. Where is your t equals to -2? It is right here. Okay, so as you can see, as t approaching -2 from left, so the value of y will be equal to 0. And as t approaching 2 from right, the value of y also equals to 0. Therefore, the limit gt as t approaching -2 is equals to 0. So, 1 mark. Okay. For question B, to evaluate limit t approaching -1, okay, so we take a look at the t equals to -1. It is right here. Okay, so we read from the graph, t approaching -1 from left. So it is here. So the value of y is -1. Okay, so and then see from right. Okay, the value of y also -1. Therefore, the limit gt as t approaching -1 from both sides is equals to -1. Okay, for question C, to evaluate limit gt as t approaching 1, okay, so 1 is right here. Okay, so but to evaluate limit gt as t approaching 1, so we take a look at the graph and the value of y is -1. From right, okay, it comes from here. Okay, so the value of y is 2. Okay, so since the limit gt as t approaching 1 from left does not equals to limit gt as t approaching 1 from right, so limit gt does not exist as t approaching 1. So we given you 1 mark for the reason and 1 mark for the answer. Okay, for question D, to evaluate limit gt as t approaching 2 from both sides, so it will be right here. This is t equals to 2. So we read from the graph. Okay, 2 from left. So over here, the value of y is 2. 2 from right, the value of y also 2. So for D, limit gt as t approaching 2 from both sides equals to 2. So 1 mark for question 1D. Okay. So we continue with question number 2. Okay, question number 2. Find limit 1 over square root 3 x cubed minus 1 as x approaching 2. So, first step, we need to substitute x equals to 2 into the function. So, 1 mark when we substitute it. Okay, then we get 1 over square root 23. Okay, so since the denominator in irrational number, so we multiply by conjugate to rationalize the denominator. So the final answer is square root of 23 over 23. So J1 for the answer. For question number 2B, okay, to evaluate limit x approaching, limit x minus 5 divided by x squared minus 25, x approaching 5 from left. So first step, we substitute 5 into the function. So substitute 5 into your x. So we get 0 over 0. Okay, since the value of limit is 0 over 0, so we need to factorize it. Okay, so how to factorize it? Okay, factorize the denominator, x minus 5 and x plus 5. So k1. And then we simplify it. We get 1 over x plus 5. Then substitute 5 into the function. Okay, 1 mark. Then final answer 1 over 10, J1. Okay. Okay, so make sure, okay, when you substitute the value of x, no more limit written in the front of the function. Okay. So question number 2. C, evaluate limit square root of x plus 6 minus 3 divided by x minus 3 as x approaching 3 from right. So substitute 3 into the function. So we get k0 over 0. Okay, since this function is in the form of surd, so to find the value of limit, we need to conjugate it. Okay, in this case, we need to conjugate. Okay, so first, multiply by conjugate. Okay, k1, and then we simplify, okay, the function. Okay, after you simplify the function, okay, so we simplify it, we get 1 over square root of x plus 6 plus 3. Okay, then we substitute 3 into the function and we get answer 1 over 6. Okay, 1 for this one, which is we substitute the limit after we simplify it. Okay, J1 for the final answer, 1 over 6. Okay. Okay, next continue with section A, question number 3. Okay, so the diagram below shows a sketch of part of the curve fx equals to 10x plus 3x squared minus x cubed. So this is the function of fx. Okay, the blue color. Okay, so the first question asks you to find the integral of fx. Okay, so integrate 10x plus 3x squared minus x cubed. So you get 10x squared divided by 2 plus 3x cubed divided by 3 minus x to the power of 4 divided by 4 plus c. So we get k1. Okay, usually we give you k1 at least 2 correct. Okay, and if you get all correct, so then you will get J1. Okay. Okay, for question B. Okay, the line x equals to 1 and x equals to 4 meets the curve at the point P and Q. So you get here x equals to 1 and x equals to 4. So it meets the curve fx at point P and Q. Okay, so kata find the area of the region bounded by the curve, the x-axis, and the line x equals to 1 and x equals to 4. So the region is right here. Okay. So to evaluate the area of the region bounded by this value, okay, so we integrate the function fx from 1 until 4. Okay, so take your integration from part A. Okay, so from part A we get 5x squared plus x cubed minus x over 4 divided by 4. We substitute 4 and 1, k1. Okay, and then we substitute. Okay, substitute x equals to 4. Make sure you substitute the upper limit first and then subtract when you substitute with lower limit. Okay, no more limit at the end of it. Okay, so K1, substitute limit, and then final answer, you get 74 1 over 4, atau you boleh tulis 74.25 J1. Okay, mana-mana satu lah. Okay, so this one for question B. Question C. Okay, the diagram below shows a sketch of fx. Find the area of the curve. Find the area of the region bounded by the curve and straight line PQ. So this is your curve and this is the straight line PQ. Okay, so you need to find the area in the yellow color. So this is the region bounded by two curves, right? Okay, so when you have region bounded by two curves, then you will use the formula. Okay, so fx2 should be your cubic function, 10x plus 3x minus x cubed. Okay, lower curve is the straight line PQ. Okay, so you need to find the straight line PQ. Okay, to substitute the function, we need to find the function PQ first. Okay, first, you need to find the point P and Q. So to find the point P, okay, since we know the value of x is 1, so we substitute 1 into the function of fx. Okay, so we get the value of y is 12. Okay, and then substitute x equals to 4 into the function of fx. We get the coordinate of y is 24. So 1p, the coordinate is 112. 1q, the coordinate is 424. Okay. Next up, okay, since PQ is a straight line, so we need to find the value of the gradient of the. Okay, so to find the gradient of PQ, we use the formula of y2 minus y1 equals to divide by x2 minus x1. Okay, so we get the gradient of PQ is 4. Okay, so K1 for the gradient PQ. After we find the gradient of PQ, we need to find the equation of PQ. So to find the straight line PQ, we substitute into the equation y minus y1 equals to m times x minus x1. Okay, then we get the equation of PQ is 4x plus 8. Okay, so K1 for the equation of PQ. Okay, so since we have the equation of PQ, then we can substitute into the formula of area. Okay, the value of lower limit is 1, upper limit is 4, upper curve is the cubic function, lower curve is a straight line. Okay, so 1 mark. Then, okay, from part B, okay, from part B, we have the value of the integral of the area under the curve, okay, from 1 until 4. Okay, so this one actually we can separate it. Okay, from 1 until 4 minus integration 1 until 4, 4x plus 8 dx. Okay, so the first one, okay, kita dah dapat nilainya daripada part B. So we just evaluate the value of the integration of 4x plus 8. Okay, so integrate 4x plus 8, we get 2x squared plus 8x. Okay, so the integration of this one is J1. Okay, then we substitute the value of limit K1. This one is K1. And the final answer is J1. Okay. Okay. So for part A, all total is 25 marks. Okay. So we continue with section B. So are you ready? Okay. In section B, question 1, we need to evaluate the limit. Okay, 9x squared divided by x modulus of x minus 3 as x approaching 3 from left. So, first up, we substitute x equals to 3. We get 0 over 0. Okay, so since we have 0 over 0, okay, so we need to factorize the function. Okay, so, but right here, we also have modulus function. So, at the same time, we need to define the modulus function. Okay, so define modulus x minus 3. So we get x minus 3 for x greater than or equals to 3. So negative x minus 3 for x less than 3. Okay, so sketch the number line. Okay, greater than or equals to 3. So we will use positive x minus 3. Less than 3. So we use the function negative x minus 3. So now we want to find 3 from left. So we will substitute the modulus x minus 3 with negative x minus 3. Okay. So 1 mark for the factorization. Okay. And a definition of modulus. Okay, after that, okay, so this one, we can cancel this one. Okay, simplify and substitute value of x. Okay, K1, and the final answer is 6, J1. Okay. Question 1B. Okay. So you have limit h divided by square root h plus 16 minus 4 as h approaching 0. So substitute h with 0, we get 0 divided by 0. Okay, so since we have square root function at the denominator, so we need to conjugate it. Okay, multiply by conjugate. 1 mark. Okay, so after we multiply by conjugate, we need to expand and simplify the function. Okay, so expand the numerator and denominator. Okay, so K1. Okay, next step, simplify, and at the same time, you need to substitute h with 0, K1, J1, for the final answer 8. Okay. Okay. So we continue with question number 2. Okay, given the function fx equals to 2 divided by x squared plus x, by using the first principle, find f prime x. Okay, note here, we need to find f prime by using first principle only. Okay, so if you use other method than that, so then we will get 0 mark. Okay, so first step, find fx plus h. So substitute x with x plus h. 1 mark. Okay, substitute into the formula of first principle, which is f prime x equals to limit h approaching 0, 1 over h multiplied by fx plus h minus fx. Okay, so substitute fx plus h and fx. Okay, 1. Okay, so after you substitute, you need to simplify the function. Okay, so how to simplify the function? You need to open all the parentheses. Okay, so open all the parentheses and simplify it. You get 1 over h multiply 2 divided by x plus h squared minus 2 over x squared plus h. Okay, so now, again, we need to simplify it again. So how to simplify the function? Because if we substitute h with 0, we still get 0 over 0, right? So to simplify the function, we need to equalize the denominator for the first two terms. Okay, so equalize the denominator. Okay, so after we equalize the denominator, okay, 1 mark for the equalizing denominator. Okay, so simplify this. So 2x squared minus 2x squared is 0. Okay, then we get h multiplied by negative 4x minus 2h divided by x squared times x plus h squared plus h. Okay, so simplify k1. Okay, so then we factorize h and divide by the denominator h. Okay, we substitute h with 0, k1, and the final answer is negative 4x cubed plus 1, okay, j1. Okay, so we continue with question number 3.
Okay, Assalamualaikum. So we will continue with question number 3 for section B. Okay, so the question asks you, given that t equals to 2x minus 5 over x and y equals to 3t minus 6t. And then the question asks you to show that dy over dx equal to 2 plus 5 over x squared, 3 plus 6x squared over 2x squared minus 5 squared. Okay, so what we have to do now is, okay, so we have to differentiate, okay, t with respect to x. So this is what we will get. Okay, so dt over dx equal to, okay, differentiate 2x, you will get 2. Differentiate minus 5 over x, you will get positive 5 over x squared. Okay, and then we need to differentiate y with respect to t. Okay, so dy over dt equals to differentiate 3t, you will get 3. Differentiate minus 6 over t, you will get positive 6 plus t squared. Okay, so you will get K1, J1 for both correct answers for dt over dx and dy over dt. Okay, what we have to do next is we need to use chain rule. Okay, so this is the concept of using chain rule. Okay, so dy over dx equals to dt over dx times dy over dt. Dy over dx is the subject that we want to show. Okay, dt over dx is we already get here, and times dy over dt also we already have up here. Okay, so we just substitute into the formula of chain rule. So you will get 2 plus 5 over x squared times 3 plus 6 over t squared. Okay, so you will get K1 for substituting into chain rule. Okay, next we need to simplify so that we can get the final answer here. Okay, so what we have to do now is we need to substitute t. Okay, we need to substitute t into 2x minus 5 over x. Okay, so this is what we get here. Okay, we just substitute t to here. Okay, and then we simplify. Okay, so 2x is actually over 1. Okay, so we need to do cross multiply so that we can get the same denominator. So times x, you will get 2x squared over 1. 1 times x, then we get the same denominator. Okay, next. Okay, so you will get k1, okay, for simplifying the denominator. Okay, and then, okay, last one. Okay, so next what we have to do is, okay, we simplify this denominator so that we can get the final solution here. So this is shown. Okay, so you will get J1. Alright, so hence find the exact value of dy over dx if x equals to 1. So it's already stated here, hence. So you need to use the answer that you get before in previous question. Okay, and then we just substitute with x equals to 1. Okay, so when x equals to 1, you just substitute into the function. So the answer is 77 over 3, or you can do it as proper fraction, 25, 2 over 3. So K1 you will get for substituting the value for x, and then J1 for the final answer. Okay, so if you see here, okay, the question asks you to give the answer in exact value. Okay, so if you give your answer in decimal places, then you will get 0 for J1 here. Okay, so exact value, which means you have to give your answer in fraction. Okay, okay, we move to question 4. Find the value of dy over dx when x equals to 2 for each of the following. Okay, so you have the first one, number 4a1. Exponent power of y equals to third x 1 minus x over 1 plus x. So how we want to differentiate this is we need to um, by taking okay, ln both sides. Okay, so why we need to put ln to both sides, because we want to, okay, simplify the exponent here. Okay, so you will get ln EY equals to ln third. Okay, x1 minus x over 1 plus x third is equals to 1 over 2 here. Okay, so by using the properties, okay, so you can bring 1 over 2 to the front. So you will get 1 over 2 ln x 1 minus x over 1 plus x. Okay, so K1 for taking ln both sides, and then another K1 you will get for using the properties of ln. Okay, bring the 1 over 2 to the front. Okay, next, this is what you will get. Okay, so ln EY is equals to y, because y you can bring to the front. So y ln e. Okay, ln e is 1. So y times 1 is y. Okay, again, by using another properties of ln, okay, so you can change ln x1 minus x. Okay, let me write it like this. Ln x plus ln 1 minus x, because we have multiply here. Okay, and then minus y minus, because we have, okay, the process of fraction here. So we need to put minus ln, okay, 1 plus x. Okay, so this is what we get here. Okay, another J1 for using the properties. Okay, and then we just differentiate directly. So 1 over 2 is a constant, so you can just write it down. Ln x, you will get 1 over x. Differentiate ln 1 minus x, you will get negative 1 over 1 minus x. Differentiate ln 1 plus x, you will get 1 over 1 plus x. Okay, alright, very easy. So you will get k1 for differentiate. And then do not forget to substitute x equals to 2. Okay, so we just substitute. Okay, let me, mm, where is the, okay, all right, so you just substitute x equals to 2, okay, into the x, so you will get 7 over 12. So k1 for substituting x, and j1 for the answer 7 over 12. Okay, so for the second one, you have y equals to ln x over 5 plus third x squared plus 4 over 5. Okay, so we want to differentiate this function. So dy dx, okay, so dy dx equals to 5 over x plus third x squared plus 4. How do we get this? We can actually simplify it first. Y is equals to ln x plus x squared plus 4 over 5. Okay, so if we want to differentiate, you will get dy over dx equals to 1 over, okay, we just copy down the function here, x plus third x squared plus 4 over 5. And then times with the differentiate of this function. Okay, so d dx x plus third x squared plus 4 over 5. Okay, so if you can see this, you have three tiers of fraction. Okay, so 1 over x plus third x squared plus 4 over 5. So if you change, you will get 5 over x plus third x squared plus 4. Okay, so this is how the process, how can we get this answer. Okay, so k1, and then we need to differentiate the function inside this bracket. So differentiate x over 5. Okay, you will get 1 over 5. Okay, let me copy down it here. X squared plus 4 times. Okay, differentiate x over 5. You get 1 over 5. Okay, differentiate third x squared plus 4, 1 over 2 over 5. So you will get plus. Okay, so you can bring 1 over 2 to the front. Okay, and then x squared plus 4. Okay, 1 over 2 minus 1, you will get minus 1 over 2. Okay, over 5 here. And then times with the differentiate inside the bracket. So differentiate x squared plus 4, you will get 2x. Okay, so if you simplify, okay, so we can bring the 1 over 5 to the outside. Okay, so k1 for this step, right? Okay, so now you can get 5 over x plus third x squared plus 4 times, okay, we factorize 1 over 5 here, okay, times 1 plus, okay, 1 over 2 times 2x, we can cancel out 2 here. So what left here is x over third x squared plus 4. Okay. All right. So another K1. Sorry. Okay, K1. And then, okay, sorry. Okay, and then we need to substitute. Okay, sorry, we need to simplify. Okay, we need to simplify so that we can get 1 over third x squared plus 4. Okay, all right. So this is the J1, the answer. And then we need to substitute the value for x equals to 2. Okay, so if we substitute x equals to 2, then you will get 1 over 2 third 2. So K1, J1. Okay, sorry if you can see the answer here because of my handwriting. Okay, so K1, J1. So remember to give your answer in exact value. Okay. All right. So question 4b. Okay, so if y equals to e power of minus 2x ln x plus 1, show that x plus 1 squared times d squared y over dx squared plus 2 dy over dx plus 2x plus 3 e power of negative 2x equals to 0. Okay, so first thing first, okay, so we need to use product rule. Why? Because we have two different functions here. Okay, we have exponent and then we have ln. So this will be our u and this will be our v. Okay, so differentiate u. Uh, you will get negative 2e minus 2x and then differentiate v equals to ln x plus 1. You will get 1 over x plus 1. Okay, and then we just substitute into the formula of product rule. Okay, so which is dy over dx equals to uv prime plus vu prime. Okay, so we just substitute. Okay, and then we simplify. So we have e power of negative 2x over x plus 1 because we multiply this together. Okay, minus 2e minus 2x ln x plus 1. Okay, so we get K1 for substituting into the product rule and then J1 for the answer. Okay, next, okay, we need to find the second derivative. Okay, so remember from the previous, okay, so this is the final answer. For first derivative, e minus 2x over x plus 1 minus 2e minus 2x ln x plus 1. Okay, if you notice, okay, we found, okay, the function for y here. Okay, so y is equals to e power of minus 2x ln x plus 1. So what we can do here, okay, is we just rewrite the first derivative as e power of minus 2x over x plus 1 minus 2y. Okay, we just rewrite into this form, minus 2y. Okay, now we can find the second derivative easily. Okay, so differentiate the second time. So you get second derivative d squared y over dx squared. Again, for this term, you have to use the quotient rule. Okay, so this will be your u and this will be your v. Okay, differentiate u e power of negative 2x, then you will get u prime equals to negative 2e minus 2x. And then your v is x plus 1. So differentiate v, you will get 1. Okay, so we just substitute into quotient rule, which is vu prime minus uv prime over v squared. Okay, so we just substitute here minus 2 dy over dx. How do we get this? Because, okay, you can see the function that we just changed just now is negative 2y. So 2 is a constant. Differentiate y, then you will get dy over dx, right? Okay, so you will get k1, j1. Okay, k1 for the correct differentiation and then j1. Okay, and then we just uh, substitute everything that we already get. Okay, x plus 1 squared comes from the question here. So x plus 1 squared. Okay, second derivative, we already get here. So we just copy down the second derivative. Okay, up until here. plus, plus 2 dy over dx. So we need to write plus 2 dy over dx. And then plus 2x plus 3 e power of negative 2x here. Okay? Alright. Okay, then we just need to simplify all of them. Okay, so if you can see, negative 2 dy over dx plus 2 dy over dx, so we can just cancel it out. Okay, because we get 0. Okay, we can cancel it. And then what left here is x plus 1 squared over x plus 1 squared. So this is also, we can cancel them. Okay, so we left with x plus 1 minus 2e power of negative 2x minus e power of negative 2x plus 2x plus 3 e power of negative 2x. Okay, alright, and then we just simplify. Okay, we just multiply them together. So x times negative 2e minus 2x, we get here. And then 1 times negative 2e minus 2x, so this is what we get. Okay, and same goes to here, we just multiply and then we get 0 as what the questions want. Okay, shown. Okay, so K1 for simplify and then J1 for equals to 0. Okay, all right, we move to question 5. Okay, so if fx equals to x squared over 2x minus 5, find the first derivative f prime and then evaluate x minus 5 over 2x minus 5 squared dx. Okay, so very easy. Okay, we need to use the quotient rule. So this will be your u and this will be your v. Okay, so u equals to x squared, so u prime is equals to 2x. Okay, v equals to 2x minus 5, v prime is equals to 2. So you just substitute to the quotient rule, and this is what you get. Okay, so K1, K1, okay, and then we just simplify. Okay, 2x squared minus 10x over 2x minus 5 squared. Okay, so we factorize 2x to the outside. Okay, so 2x and then x minus 5 over 2x minus 5 squared. Okay, and then J1. Alright, now we want to find the definite integral for x minus 5 over 2x minus 5 squared dx. Okay, so the interesting here, uh, if you can see, okay, so x minus 5 over 2x minus 5 squared, okay, already you already get here. Okay, so now we can apply the concept of antiderivative. Okay, integration uh, is antiderivative. Okay, all right. Okay, so uh, if you have fx and then you differentiate, then you will get f prime x. Okay, so since it is antiderivative, so if you integrate, okay, let's say if I integrate f prime x dx, then you will get fx. Okay, so all right. Right, so x minus 5 over 2x minus 5 squared dx is equals to 1 over 2, okay, 2x x minus 5 over 2x minus 5 squared dx. Right, so you will get k1 here. Okay, and then see, right, 2x. Okay, we can cancel out here 2 and 2. So the left, what left here is integrate, okay, x minus 5, sorry, x minus 5 over 2x minus 5 squared dx. Okay, so this is your f prime. Okay, so this is your f prime. All right, so f prime, if we integrate f prime dx, then you will get, okay, fx. Okay, all right, so we just substitute the function of fx here. So x squared over 2x minus 5. Okay, and then do not to put plus c because this is the definite integral. Okay, and the limit is 1 and 2. Okay, so we just substitute. Okay, 2 into x minus, Okay, substitute 1 into x. So you will get negative 11 over 6. Okay, so K1 is the mark for substitution, the value of x, and in J1 is negative 11 over 6. Okay, alright. Okay, for 5b, given y equals to sine 3x over 1 minus cos 3x. Again, we need to use the quotient rule. So this will be your u and this will be your v. Okay, alright. So u is sine 3x. So differentiate u prime, you will get 3 cos 3x. Okay, v is 1 minus cos 3x. So differentiate v, you will get v prime equal to 3. Differentiate cos, you will get negative sign, but negative negative here, so we get positive. So positive sine 3x. Okay, so we just substitute into the quotient rule. Then you will get K1 here. Okay, so K1, okay, for the correct differentiation of u, okay, K1 for the correct differentiation for v, and then another K1 for substituting into the quotient rule. Okay, alright. So we just simplify. Okay, so we get 3 cos 3x minus 3 cos squared 3x minus 3 sin squared 3x over 1 minus cos 3x squared. Okay, so another K1 for simplifying. Okay, so you will get 3 cos 3x minus 3 cos squared 3x plus 3 sin squared 3x. Okay, we factorize. Okay, cos squared and the sin squared. Okay. Okay, so by using the properties, remember, okay, so cos squared 3x plus sin squared 3x is equal to 1. Okay, so we just substitute 1 to here. Okay, oh sorry, 1 to here. So that's why we get 3 times 1. Okay, so we just factorize. So now we can show that dy over dx is equals to negative 3 over 1 minus cos 3x. Okay. Okay, now we proceed to question 6a. Okay, integrate 1 to 3 for 3 4t minus 5 over 2 5 minus 4t cube dt. Okay, alright. What we have to do here is, okay, as you can see, okay, we can simplify the function on top. Okay, so we bring negative to the outside. So we get integrate 1 over 3 negative 3 5 minus 4t. Okay, we just factorize the negative outside. Okay, over 2 5. So now we can cancel here so that we can get, okay, so we can get integrate 1 2 3. So we factorize negative 3 over 2 outside. So we left with 1 over 5 minus 4t squared dt. Okay, so we can bring the function to the top to use the power rule. Integrate by using the power rule because this is linear. Okay, the function inside the bracket is linear, so we can use the power rule. So negative 2 plus 1, you get negative 1, divide by negative 1 times negative 4. It came from differentiate the function inside. 5 minus 40, differentiate, we get negative 4. And then we just substitute. Okay, just substitute the value. 3 into t and 1 into t. So you will get K1 for substitution and then J1 for the final answer, 9 over 28. Okay, so for question 6b, okay, by substituting t equals to 1 plus y squared, evaluate y cube over 1 plus y squared cube dy. Okay, so differentiate t, you will get dt over dy equals to 2y. So make dy as the subject, so you will get dt over 2y. Okay, for K1 for this value. Okay, and then so we need to find the new limit for t. This is the limit for y. Okay, alright. So what we want to find the limit for t. So we just substitute when y equals to 0. So t equals to 1. When y equals to 1, t is equals to 2. So this is the new limit for t, for variable t. Okay? Alright, so we substitute. So y cube over t cube dt over dy. Okay? So we can bring 1 over 2 to the outside. We factorize the constant. Okay? Y squared here. Okay? Since t is equals to 1 plus y squared, so we can make y squared as the subject. So y squared equals to t minus 1, so that we can substitute here. Okay, so we get t minus 1 over t cube dt. Okay, so we get k1, and then we just simplify. T over t cube is t power of negative 2. 1 over t cube is t power of negative 3. So we can integrate as usual. Okay, t minus 2, you get negative 1 over t. T power of negative 3, you get positive 1 over 2t squared. Okay, so we just substitute, okay, 2 and 1 into the function. So you will get 1 over 16 as the final answer. Okay, now we reach the last question, which is question 7. Okay, so you have the region S is bounded by the curve y equals to ln x, the x-axis, the line x equals to 1 and x equals to 3. And then question A, find the area of the region S. Okay, if you want to see the graph, it's actually look like this. Okay, this is the graph for y equals to ln x. Okay, so this is x equals to 1. Okay, you can check when x equals to 1, y equals to 0. Ln 1 is 0. Okay, and then this is x equals to 3. So this is the region, okay, that you want to find. Okay, the area of the region that you want to find here, region S. Okay, so ln x, okay, ln x here, okay, minus 0. Okay, so integrate 1 to 3 ln x dx. So remember, if you want to integrate ln x, we need to use by part. Okay, so u equals to ln x. So differentiate du, you get 1 over x dx. This we need to use by part. Okay, and then dv, the left is dx. So differentiate dv, you will get v equals to x. And then we just substitute into the formula of by part. Remember, okay, integrate u dv is equals to uv minus integrate v du. Okay, so we just substitute into the formula. So this is what you will get. X ln x minus integrate 1 to 3 x, okay, times 1 over x dx. K1 for substituting into the formula. Okay, alright, so this is what you get. Okay, x x. Okay, you can cancel out. So integrate 1, you will get x. Okay, so x ln x minus x, and the limit is from 1 to 3. So we just substitute 3 and 1 into the function. So you will get 3 ln 3 minus 2 units squared. Okay, K1, J1 for the marks. Okay, for question B, the region S is rotated through pi radian. Okay, determine the volume of the solid generated. Okay, now you have to be careful with the question. Alright, so as you know, okay, pi radian is 180. Why? Because 2 pi is 360 degrees. So when pi, which means 180 degrees. Okay, so the formula for volume is V equals to pi integrate, okay, y outer squared minus y inner squared dx. Okay, alright, so this is the general formula. Okay, but since, okay, since the region is rotated pi radian, okay, it means the solid, okay, is halfly rotated. Okay, alright, so we need to divide by 2. Okay, so actually the formula is 1 over 2 pi integrate, okay, y outer squared minus y inner squared dx. Okay, 1 over 2 comes from Okay, because it rotated, okay, pi radian about the x-axis. So we need to divide by 2. Okay, all right. So again, we need to use the by part. Okay, so ln x squared is the formula. Okay, your y outer is ln x from the previous graph here. So this is your y outer. Okay, and then okay, we substitute into the formula. So you will get pi over 2 integrate from 1 to 3 ln x squared. Okay, dx. Again, we need to use another by part. Okay, so u is ln x squared. So differentiate u, you will get 2, bring to the front. Okay, and then ln x. And then differentiate ln x, you will get 1 over x. So that's why du is equal to 2 over x ln x dx. Okay, differentiate dv dx is equal to v dx. Okay. Okay, and then we just substitute into the formula of pi part. Okay, so remember you have pi over 2 here. Okay, and then uv minus integrate v du. Okay, pi over 2 comes from the formula, the earlier one. Okay, so uv is ln x squared minus, okay, integrate v du. So this is what you get. Okay, as you can see here, okay, so we can cancel out x and x here. So we left with pi over 2x ln x squared minus 2x ln x minus x. We need to use another by part here. Okay, so integrate ln x, you already get from the previous question, 7a, so we can just substitute here. Okay, so integrate ln x, you will get x ln x minus x. Okay, the limit is from 1 to 3, so we just substitute. Okay, let me write down here. We need to use another by part here. Okay, right. So we just substitute with 1 to 3, and then you will get the final answer is 3 ln 3 minus 2 unit cube. Okay, because of this is volume. Okay, all right. So K1, J1 for the final answer. Okay, I think that's all for Muafakat set 8. And I wish you all the best for your PSPM2. Study smart, work hard. Okay, all right. Thank you. That's all. Assalamualaikum warahmatullahi wabarakatuh.